Hey math kids, we're going to finish up talking about the binomial theorem, but this time we're going to allow rational exponents. And so we use this new formula for that situation. And on this first problem, we're given 1 over the square root of 2 plus x. That doesn't really look like a binomial expansion, but we could write it like this, because remember, square root raises things to a exponent of 1/2, and then since it's on the bottom, we bring it up top, we need to change it to a negative. So now we're going to try to expand this, and now it looks like this. So our a is 2, our bx is x, our n is negative 1/2, and then we'll go through all the different values of r. So let's first just find this an value. So a to the n is going to be 2 to the negative 1/2. That's our a to the n. Now we're going to go through each piece. They only want us to find the first 4. So we're going to look at r equals 0, 1, 2, and 3 to do that. So we'll plug that in. So n is always negative 1/2. And let's see. And then our r value will be our r. Our bx will always be x. Our a will always be 2. And our r value will be r. So if we plug these in, what we're going to do, we're going to plug in a 0, and remember that just goes to 1, and that's just a 0 as well. So overall it's just going to be 1 times 1 for our first one. Once again, if the r is a 0, this combination goes to a 1. If this is a 0, anything raised to the 0 is 1. 1 times 1 is 1. Okay. Next thing, if we do this next part, we're going to get negative 1/2 r is 1, and we get x over 2 raised to the 1. And we'll get a combination right here, negative 1/2, 2, x over 2 raised to the 2, and then negative 1/2, 3, x over 2 to the 3. All right. Now, we need to go back to how combinations were defined in the beginning. And so a combination is defined as n times n minus 1 times n minus 2 dot 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 until we get to n minus r plus 1. So in this case, that's also divided by r factorial. When we're doing this over here, so raising this to 1, that doesn't matter. We can get rid of that. If we're talking about this, our n value is negative 1/2, and we want to find out what our n minus r plus 1 value is. So that's going to be negative 1/2 minus 1 plus 1. So those cancel. So in this case, we're only going to have the 1 value on top of that, and then divide it by r factorial. So this is going to be negative 1/2 divided by r factorial. R on this one was just a 1, so 1 factorial, which is just 1. Okay. Now we're going to figure this one out. So once again, we need to figure out n minus r plus 1. So we're going to say negative 1/2 minus 2 plus 1. That's negative 1/2 minus 1. And so that's negative 3/2. So when we're doing this, it's going to be negative 1/2 times negative 3/2. And that's going to be over r factorial, which is 2 factorial. And then we have x halves squared. Okay, you're probably noticing this pattern. We're just going to go to the next one down. So it's going to be negative 1/2, negative 3/2, negative 5/2 over 3 factorial x halves to the 3. Whoops, that's not a plus sign. There we go. Alright, we just need to keep going. Okay, negative 1/2 divided by 1 is just going to be negative 1/2. This one, we can do negative 1 times negative 3, which will give us a positive 3. 2 times 2, which is going to give us a 4. And then if we do 3/4 divided by 2 factorial is just 2. We can flip the second one. So we're going to get 3/8. Okay, multiply the tops together. We're going to get negative 15. Multiply the bottom, 2 times 2 times 2, that's 8. 3 factorial is 3, 2, 1, so that's 6. So we get negative 15 over 8 divided by 6, which would be like multiplying by 1/6. And 6 and 15 are both divisible by 3. And so we'll get negative 5/16. We have x halves cubed. Alright, now we can continue to simplify this. So that's still a 1. Multiply the tops here, negative x over 4. This is really x squared over 4 when we distribute that. And so we're going to end up with 3x squared over 32. And then this one over here, we're going to get x cubed and 8 on the bottom. So we'll get minus 5x cubed over 16 times 8. 128. Alright, so that's it for part A on there. Now part B, state the interval of convergence for the complete expansion. So the interval of convergence, you can just find it in your book, and so it just looks like this. So we just need to find A over B to do that. And so where did we write down our values? Okay. So what are we doing? So A over B is going to just be 2 over 1, because B is really just a 1, because bx is x, looking right here. So we get negative absolute value 2 over 1 is less than x is less than 2 over 1. And so that's just, when we simplify that, it's just negative 2 is less than x is less than 2. And so that's our interval of convergence. And then it says use the expansion to estimate the value of 1 over the square root of 2.1. Check your answer by direct calculation. Okay, so if we look at the thing we found right here in red, let's see, we can get rid of all this, I think. Okay, if we look at this, oh, you know what I left out though? All of this needed to be multiplied by our a to the n value right here. So 2 to the negative 1/2. Okay, this entire thing should have been the answer for part A. Now, going back to this though, what we're going to do is we're going to plug in, let's see, let's look at our original. Do we still have it? Yeah, there we go. Okay, so we have the original right here, and we're asked to do 1 over the square root of 2.1, so that means that x is equal to 0.1. So we're going to plug in 0.1 for this thing. So we're going to say 1 minus 0.1 over 4 plus 3 times 0.1 squared minus 5.1 cubed. And then all of that needs to be multiplied by 2 to the negative 1/2. Okay, so if we do that, we're going to say 0.1 divided by 4, 0.025. Then we're going to do 0.1 squared times 3 divided by 32. And we get 9.37, what was that? 5 times 10 to the negative 4. And then we're going to do 0.1 raised to the 3 times negative 5 divided by 128. Okay, so I'm going to just keep that number right there, and then I'm going to add 9.375 times 10 to the negative 4, and then I'm going to subtract 0.025, then I'm going to add 1. Alright, so everything in the parentheses right here should be is that number that we can see on the screen. Now I just need to multiply that by 2 to the negative 0.5. Alright, and we got 0.69006, etc. So that's the estimation for that. Now let's actually plug that in. 1 divided by the square root of 2.1, and we see that it's a very close, it's not exactly the same, but it was a really close to what we found. If you need additional help, please come to Math Lab. Until then, calculator.